Hello and welcome back. Today we're going to look at geometric sequences and series. So geometric sequences and series have a common ratio. So the ratio is determined by dividing a term and then its previous term. So looking at two consecutive terms. So we should have a ratio, common ratio, such as a2 over a sub 1 would be equal to a sub 3 over a sub 2. And you can figure that ratio pretty quickly. To find the nth term, we will need to use exponents. So we're going to raise that r to a power. So you can see that in the formula, a sub n, the nth term, is going to be equal to the first term times r raised to the n minus 1. So when we look at that sequence, the first term is just a sub 1. And then we multiply a sub 1 by r to get a sub 2. To get a sub 3, we're going to raise the r or square the r and then multiply by a sub 1. To find the fourth term, we're going to have to cube the r and then multiply by a sub 1. So we're always subtracting 1 from n to find that exponent. Okay, so for these geometric sequences, we're going to find r, find the common ratio. And it's really easy to figure this one out. So each time we're multiplying by 3, and you could see 3 raised to the n. Well, the r must be 3. Here we're doubling everything, so the r must be 2. And here we're multiplying everything by negative 1/4 or dividing by negative 4 as well. And you can say r equals negative 1/4. So the ratio is always what you're multiplying by. Let's find the first 5 terms of the geometric sequence whose first term is 1 and the common ratio is negative 3. So we start with 1 and we're just going to multiply by negative 3. That's pretty easy to figure out. So 1, negative 3, 9, negative 27, and 81. For example 3, we're going to find the 9th term of the geometric sequence, given that the first term is 4. I'm going to write this here. So a sub 1 is 4, and then the common ratio is 1/2. So we can write the formula here. So our a sub n will be 4 times 1/2 to the n minus 1. And if we want to find the 9th term, we're really going to, the a to sub 9, we're really going to raise 1/2 to the 8th power. So when we reduce that, we'll get 1 over 64. For example 4, we're going to find the 10th term of this geometric sequence. So a sub 1 will be 6, and then the ratio, well, each of those terms are being divided by negative 3, or you could say multiplied by negative 1/3. So if we want to find the 10th term, we need to write the formula first. That's 6 times negative 1/3 raised to the n minus 1. So a sub 10 will just be 6 times negative 1/3 raised to the 9th. And we can simplify that. I get 6 over negative 19,683. And that reduces to 2 over negative 6,561. So that'll be the 10th term in that geometric sequence. For example 5, we're given that the second term is negative 18, and the 5th term is 2/3. So we definitely know that there's a relationship between these. So if I was going to figure out the 5th term from the second term, I would have to raise that ratio to the third, right? Because 5 minus 2 is 3. So if I know that a sub 5, this is 2/3, and this is negative 18, well, I can isolate r cubed, and I'll get negative 1 over 27. So r must be negative 1/3. So if I know that that equals negative 1/3, I just need to multiply this term by this r. So we have 2/3 times negative 1/3, and so our 6th term would be negative 2/9. Okay, so just like we had done for arithmetic sequences, we can actually find the sum of geometric sequences. So I'm going to just walk through the proof with you. So if we know that the sum of the geometric sequence, I'm just going to write them out. There's the first few terms. So we have a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus a sub 1 r cubed. It's going to keep going till we have a sub 1 times r to the n minus 1. And just like we found the fraction for the repeating decimal, I'm going to multiply both sides by r. So we have r times s sub n. And so all of these will be multiplied with a higher power of r. So a sub 1 r squared, a sub 1 r cubed. And then we're going to keep going, and it'll be a sub 1 r to the n. And what I'd like to do is subtract the second line from the first line. So we'll have s sub n minus r times s sub n. And if you notice, all of these terms are going to cancel here right in the middle. Right? This one would probably be right before. And so we know that we'll have a sub 1 minus a sub 1 times r to the n on the right side. So I'm going to factor the common terms. So look at both sides. So let me factor s sub n. And we'll be left with 1 minus r. And here I'll factor out a sub 1. So 1 minus r raised to the n. And if we want to find that sum of n terms, we could divide both sides by 1 minus r. So it would be a sub 1, 1 minus r to the n over 1 minus r. So you can see that formula is going to be right below if we want to find that sum. So we always want to find the first term, know the number of terms are going to be in that sequence, and the ratio. Okay, so let's try this one. So here we have 2 raised to the n minus 1. So if we find that first term, that's going to be 2 raised to the 0, which is just 1. We know we want the 7 terms, and we know the ratio is just 2. So we'll have 1, and I don't need to write it, but we'll have 1 minus 2 to the 7th over 1 minus 2. So that's 1 minus 128 over negative 1. And so that'll be 127. For the next one, all right, so finding these terms. So a sub 1 would be 4 times, this will just become, I'll write it out, but 0.3 raised to the 0, right? So that's just 4. And then we know we're going to have 12 terms here. That's always the number up at the top. And our ratio is 0.3. So it'll be 4 times 1 minus, and put that ratio there, 0.3 raised to the 12th over 1 minus 0.3. And this will be a crazy number, so I'm going to round it. It'll be about 5.714. Okay, so looking at this next one, it looks very similar to the one right before. But just notice that this exponent was I minus 1, and this exponent for the next one is just I. So just be careful when you're finding that first term, it's going to be different. So 4 times 0.3 raised to the 1 is that first term. We're still having 12 terms. The ratio is still 0.3, but we're going to have the formula as 4 times 0.3, and then 1 minus 0.3 raised to the 12th over 1 minus 0.3. And that will be about 1.714. Okay, now let's find the sum of an infinite geometric series. So there are 2 caveats. We have to make sure if we're going to find the sum, the absolute value of r is less than or equal to 1. Because as n increases, as n approaches infinity, that rate, that r raised to the n, is going to approach 0. So we can actually simplify this formula because it'll be 1 minus 0 on the top, and we can rewrite this as the a sub 1 just divided by 1 minus r. So it looks a lot like the sum of a finite series. So Quick thing we want to make sure we remember though is that the absolute value of r has to be less than or equal to 1. When it's greater than 1, we won't be able to find the sum, right? Because the value will be approaching infinity, keep getting bigger and bigger. Okay, so let's find the sum of these series. So the first term, you can see it really clearly, is going to be 5 times 0.5 to the 0, so just 1. And then we know that r is 0.5, so it'll just be 5 over 1 minus 0.5. So 5 over 0.5 is just 10. For the next one, we have a series here, and you could tell that it's geometric as well because each consecutive term is being multiplied by 1/5 or divided by 5. So our first term again is 5. Our ratio is going to be 1/5. So if we're going to find the sum of that, we can write that here. So we're going to find the sum of these, and I'll just rewrite this as going to be 5 1/5, and we're going to go to infinity and 0. So this will be 5 over 1 minus 1/5. And so 5 divided by 4/5, or 5 times 5/4, would give us 29 over 4. Now for this last example, we're going to look at compounded interest. So we're going to deposit $100 into the account every month, on the first day of every month, and it's going to pay 6% interest compounded monthly. So that's going to be 0.06 over 12, and that's going to be the general rate. So here we have 100. Let me simplify this. The ratio would be 1.005. So that's going to be our first term, or a sub 1. And then we want to find the balance after 4 years. So that's really going to be 48 months, right? So we want to find when n equals 48. So we know our r is going to be 1.005, and our a sub 1 is going to be that product. So if we want to find the sum after 48 months, we're going to multiply that first term, that first value, by 1 minus the rate raised to the 48 over 1 minus the rate, 0.005. All right, and when we put that in the calculator, we'll have $5,436.83. Okay, so hope that was helpful, and I will see you all in class.